computers are. This session is a lighter session. I promise I won't overrun. No overrunning on this session because it's a light session and we talk about the operating system and exactly what that is. Okay, we don't have any Kahoot, but we will introduce you later on in the session to Kodio, which is the platform that we access our virtual machines from. And you can have a little play and we do a little dive into that sets you up for the future sessions where we dive into the operating systems themselves and we give you virtual machines that you can then break rather than breaking your own machine and not being able to connect to us. Okay, so without further ado then, let me crack on to what is behind the scenes. So we're going to give you a grasp of the fundamentals in the operating system, what different parts of an operating system do. So we'll talk a little bit about OSs, the kernels, the firmware, software, boot methods. So we'll go into that in a bit more detail. And we will understand the different operating systems themselves. So what is a partition, what basically happens where, and we'll talk around those subjects. Now today, it's a very open session. So live chat, any comments, please throw them in there. Any questions, we have got time today to basically pick up all those minor issues you may have, and we should be able to get through those. And as I say, please throw those in at any time during the lectures. So let's have a look at it. The purpose of an operating system. The general definition of an operating system, or OS, it's sometimes abbreviated to OS, is software that manages the computer hardware and software resources. So it kind of organizes things. It manages the resources and allows things such as your applications or other software to talk to the hardware. So it provides common services for the computer program. It handles basic system tasks such as the memory and your storage, as well as your network and security. It has to do an awful lot around it because what it does is it talks from the application to the operating system and then to the hardware. So your application doesn't need to know anything about the hardware. It just needs to talk to the operating system and say, can you do this for me? The operating system will then talk to the hardware. We'll go into a little bit of details about that. And it kind of interacts between the user itself. It's the interface that the user tends to use to integrate with the computer system itself. Now, there are different types of operating system. Okay, Windows. Well, we all know and love Windows. No, that's not really true, is it? I know we've got several Mac users out here. Okay, so Windows is the most popular desktop operating system. Okay, it's produced by Microsoft, Windows 10, Windows 11. It is what we term as a closed source. That means no one can modify that source code. It's written by Microsoft. It's given to you by Microsoft. You cannot change that product itself. Then we have the Mac OS, sometimes called OS X. Now, the Mac was basically written by Apple Macintosh. And when we talk about the Mac operating system later on, we'll go into a lot more details on it. It is based on a product called Unix. Okay, so it was derived from Unix. Okay, it's tightly integrated with the Mac hardware, as in if you buy a Mac operating system, it runs on Apple hardware. It doesn't run on any other hardware. It runs on the Apple hardware only. And of course, that makes it nice because it is less prone to any conflicts, less prone to falling over, so to speak, because it is designed simply to run on its own operating system. There isn't any third-party hardware that comes and gets involved and gets in the way. It is simply a one-stop shop, so to speak. It is what is known as closed source again. You cannot take the Mac operating system and change it. You cannot modify it, resell it, use it, make any changes to it. You can pretty much use it as you like, but you can't make any changes to that. So very similar to the Windows operating system. Then we have Linux. Okay, Linux, we change things up because Linux is open source operating system. There are many distributions of Linux, such as Ubuntu, Red Hat, Debian. These are all highly customizable operating systems. And we'll go through the history of it all and basically how it all came apart. But basically, Unix got developed, and some people basically said, oh, we don't actually want just to run Unix. We want to write our own, for example, file system. We want to write our own graphical interface. We want to write our own handler for crunching numbers. And that then basically meant that people just went off and they wrote their own pieces of code for the operating system. That makes it beautifully customizable, but because it's open source, you have to talk about support. And we'll go into that in more details when we talk closer about those items. Unix. Now, we owe Unix a great deal because, as you've just heard, Linux and the Mac OS basically are derived from this. So Unix was an early multi-user, multitasking operating system, basically developed by a company called Bell Labs. Okay, so it did inspire Mac OS and Linux. Okay, it was a forerunner, essentially. The reason we have Mac OS and Linux spin-off is because Unix was very tied down. It was like the Microsoft operating system. It's proprietary, it's fairly expensive, and it tended to be run on bigger systems. That kind of is the stuff that you see on your desktops. Then we have mobile phone devices and mobile devices. So iOS is the Apple equivalent of a phone operating system. Runs on our phones, our iPads. Again, this becomes a closed source product. And we have Android. So Android essentially is the Google open source. So it is actually sneakily based on Linux in there, okay? And it gets customized by each individual manufacturer. So if you run a Samsung with an Android operating system on it, it's customized for the Samsung hardware by Samsung, strangely enough. Okay, and you can basically do what you fancy with it. And then there's other products, such as Real-Time OS, which is an operating system that was optimized for real-time applications, just pretty much like it says on the tin, like robotics and industry controls. It is designed to be highly reliable because you don't want your robotics and your industrial control stuff to fall over and have problems. So it is very reliable real-time systems. Anyone got any questions around those different types of operating systems? We tend to break them down into the ones on the top row, top shelf, so to speak, that run on your desktops, your laptops, your servers, and the other items on the bottom row that basically run on your mobile devices, such as your phones and your tablet. I can see Marcos typing now. I'll have a sip of my coffee while he finishes his letter. Hopefully he's not just lent on his keyboard. Okay, we're going to tick on to the next slide and see what Marcus brings up in a minute. We're happy to jump backwards and forwards in this lecture because, as I said, we've got some time. Marcus, don't let me interrupt your typing. Please carry on. So, a general description of common operating systems. We've kind of gone through this before, haven't we? Microsoft. Okay, Marcus is finished. In a Macintosh system, you can install Windows. Yes, you can. But you do it on a Windows systems install Mac. Okay, yes, you're not supposed to. Let's put it like that. There's a certain legal caveats. I think the new operating system allows you to, but there definitely were caveats where Apple basically said this must run on our hardware. Okay, and I think it's basically called a Hackintosh when you actually do it, because it is a hack and you're not supposed to do it. Does that answer that question for you, Marcos? Great stuff. Okay, so we've said that Microsoft Windows, it's a closed system. But if you look there, we basically give you a very attractive chart that shows you who owns what. The Windows market share worldwide is around the 70% mark. You can see how dramatically larger that is than the OS X, which is the line below, which is running about the 16, 17% mark. And this is very simply because big companies basically settled with a Microsoft operating system years and years ago. Apple were unable to break into that. A big reason they were unable to break into that was the cost. Okay, the Windows-based operating system or DOS disk operating systems were significantly cheaper, and the hardware was significantly cheaper than the Apple environment. So if you're likely to get a job, first line technician or anything like that, 80% of the time you are going to be supporting PC, as in the Windows operating system. Linux is there as well. Linux is open source, but there's so many different flavors of Linux. Even when we bundle them together, they are still not coming out at massive numbers there. Okay, they are great. The Linux is about 3.5%, 4%. There are other operating systems that are more popular than Linux, around about 4 and a bit. And of course, there's Chrome OS, which is basically a operating system for Chrome itself. What we see on Chromebooks, which are the laptops that simply run a browser system rather than a full-blown operating system. Any questions about market shares then? Great. Okay, so let's have a little introduction to a mobile operating system as well. So we know the mobile operating systems run on our smartphones, Galaxies, iPhones, Google Pixels, etc., etc. They are complex devices. They are tiny, they are small, they can be big, depending on what you basically want to run them on. Again, we're looking here at the mobile OS tablet operating system market share worldwide. Android still outstrips Apple. You wouldn't have thought that. That's basically because Android is a cheaper system and it is used more in the business environment than it is basically on our personal devices. I run an iPhone, to my shame. I say to my shame. They're great. They're beautiful toys, aren't they? They're fantastic. But in a business environment, we probably end up with an Android. They are cheaper for the business to purchase and business to run and manage. And that's why we have the difference there. We have Android running about 70% and the Apple iOS running the rest of it. Let's have a quick poll then. Let's have a poll. Let's see in the live chat, can you type in iOS if you're running an Apple and you can type Android if you want to type it all if you're running an Android system. We'll see how many we get. Or iOS are smashing it up. That's probably because Android's a bit longer to type, isn't it? 3, 4, 5. Both. Adam, you just greedy. Paul's running a bespoke one there. Pixel 6a running a Graphene OS. So there are other OSs out there. Precious Android, Joseph Android, Olayinka, iOS. Again, I apologize if I get anyone's names wrong. Calban Android, joking. Is that a joke, joking? I must apologize if I kind of get that slightly wrong. Ethan, iOS. Marcus, old BlackBerry. Who remembers the old BlackBerries? For those of you who don't know, before we had the beautiful smart touch screens and things like that that are so common in our devices, there was a company called BlackBerry, and it produced essentially a phone that had a physical keyboard attached to it. So you had a very small top screen and then a keyboard literally underneath, and you type away. And it was one of the beautiful ones because you can access emails and all that sort of stuff. It's first revolutionized. It was beautiful. But what they did was they kind of went, oh, we've got a great product. Now we're going to go down the pub. And they literally fell asleep. Everyone else started producing things on smartphones that were using touch screens. So we wouldn't have a keyboard. We'd develop a keyboard into the touch screens, which is essentially what Androids and the iOS do. And BlackBerry went, no, we're fine. We're still down the pub. And they fell asleep. And the market just went from underneath them. And business just went, well, we don't want these rubbish ones because you've got a keyboard that takes up half the space. Why can't we just have a in a big picture. So they were great. Everyone loved them at the time. And then literally got to move with the market, I think is the way to look at that one. So I think basically having looked through the live chat, roughly, I think it was probably 50-50, which is pretty much what we expect from personal users. Good. Anyone got any questions about iOS's and the operating systems we run on our tablets? Give you a good guess there on the market share, isn't it? Paul Bird loved Blackberries. They were amazing. They were revolutionary when they came out. The old-fashioned way you used to remember, you had the keypads that went 1, 2, 3, 4, 5, 6, 7, etc., and they had letters on them. Before BlackBerry came out, that's how you had to type a text message. You press number 1 3 times to get C, and then I can't remember the other letters now. So literally, it was a case you press 1 3 times, you got C. 5 twice, you got I, etc., etc. So it was like that. BlackBerry came out, tiny keyboard. Okay, so that's the mobile OSs. I worked for T-Mobile when they came out. Fantastic times, Paul. Crikey. Sounds like you're my era, Paul. Well done. Every single salesman wanted a BlackBerry. That was it. Give me a BlackBerry. Give me a BlackBerry. Good fun. Okay, so that's kind of covered what's out there. So we now know what is out there for us to get. Let's have a little look, essentially, at what I term the magic behind the operating system. So the operating system basically comes in several different parts. Okay, at the top of the tree, we'd build it into this beautiful little pyramid for you just to help things. The top of that pyramid is the user interface. This is really important because it is where your user interacts with the operating system. Okay, it allows them to run applications, keyboard input, display. Really, it's the user interface. It's an important part of the system. Then there's the kernel. Now, the kernel essentially is the core. That's why we put it in the middle. The kernel is the core that manages the essential tasks, okay, such as processing memory, interacting directly with the hardware. Okay, this is the one piece that tends not to change massively in a custom operating system. If you look at a Linux operating system, the chances are that core still goes back essentially to that initial kernel that was produced years and years ago, because that's the piece that handles all the other pieces. And the bits on the outside do all the fun stuff. So then bolted on the side, we have device drivers. These manage essentially the chats between the memory and the hardware. So if you install, say, for example, another graphics card in your machine, that comes with a device driver. So if you change that, the kernel doesn't need to be updated. All you're updating is the device driver that sits on the side. Very much the same if you put a different network card in or multiple network cards in. You are just adding another device driver onto the side. You are not changing that core that is the kernel. That kernel does exactly the same thing. And then last but definitely not least is the system utilities. So these are basically going to perform specific tasks. System diagnostics, network monitoring, enhanced system management, and some of the user experience. So all these 4 items basically form your operating system. The key piece to remember is the piece in the middle, the kernel, is really where the thinking and the brains are. And that's the piece that tends not to change so much. Any questions around parts of that operating system? So let's have a little bit of a further look into kernel definitions and functions. So it does the memory management. This is managing memory allocations and access to memory resources. The kernel allows you to separate memory. Okay, without the kernel, you would have individual applications talking directly to the memory and therefore writing over each other's memory. The kernel is the piece that sits in the middle and says, this is your piece of memory, Microsoft Word, and this is your piece of memory, Microsoft Excel. I will not let you talk to each other's memory and wipe out what each other is doing. It does the process management, so it handles the scheduling of processes and your multi-threading on the CPU. So it handles those and makes sure that no one bumps into each other and everyone is playing nicely. And it queues them up, hands them all to the processor, and then gets the results back and passes it back out to wherever it needs to be. It manages the device drivers. So although we say, the device drivers are a separate section, they are managed by the kernel. So the kernel is the one that's in charge, pokes data to and from the device drivers that function with the hardware. File system management. We haven't mentioned the file system before. We will dip a little bit further deeper into it later on in the content. But it manages the file system itself. So writing to and from your disk drive, be that an SSD, a hard disk drive, or essentially a tape drive or any other form. It also manages the network. So it manages your network functionality, the communication, and it provides an essential part in the protocols for some of the data transition. We'll talk more about some protocols when we talk about our network sections. And then it handles our system calls and security. So this is really an interface for programs to access the system resources and hardware. So it gives an interface that all applications can talk to in a very friendly manner. So really, in summary, the kernel handles the core management tasks within your operating system. So it provides the essential bridge between the application itself, your application, and the physical components of that computer. So here's just a brief list of some of the items that it covers. So a kernel is the central module of the operating system. It handles low-level tasks such as memory and processors and drivers. Okay, and the typical kernels are, we've got a Linux kernel, Windows NT kernel, are examples of OS kernels. And the kernel operates in a privileged mode. So the kernel is the only item on your system that accesses in a privileged mode. That means it has full access to all the hardware. Everything else must talk to the kernel to do anything else. Okay, and the kernel is there to basically provide the basic level of services for system programmers. So how does that look in terms of a pretty picture? Okay, so under the hood, what you have is you have your operating system that sits in the big orange box, and that sits on top of the computer hardware. So nothing goes to the hardware unless it talks to the operating system. There are cases where that is different, and we will tackle that later. Think of this as the core, essentially. Your applications sit on top of that operating system, and they talk to the operating system. So if they want something printed, they talk to the operating system. If they want something displayed on the screen, they talk to the operating system. And you have your user input and output. So your user input works with the application. We talk to the application. So any keyboard stroke itself doesn't come from the user input. It comes through the operating system and then to the application itself, because it's deemed as a piece of hardware. But the users basically interact with applications that function on the operating system that then works with the computer hardware. So you can see the flows will go backwards and forwards in that. And if we expand out as we've done there, the operating system, we see the kernel basically sits as a core part of the operating system. And it interacts with the computer hardware. So it talks to the CPU, talks to the memory, the disk drives, the USBs. So it talks to all those items. So remember, a kernel is a core component of the operating system, but it is not the operating system in its entirety. Remember our beautiful little pyramid that we had? There are the other items around there. So if a calculation needs to be performed, the kernel communicates that to the CPU. The kernel doesn't do the work, it basically passes it to the CPU. The core processing unit will then complete that information and pass the information back. The kernel then drops it onto the application. If a file is written to disk, the kernel communicates with the disk storage to say, this is where I want you to write it. So it controls where it is written onto your hard disk drive or SSD. And the kernel is in charge of all resource management. So having a really well-built kernel is key for security as well, because it prevents other applications from writing across other applications' memory or accessing things that they should not be accessing. Any questions about what the kernel basically does and how to think of the kernel? Let's have a thumbs up if you totally understood what I've gone through there. Thank you very much, Marcos. Pass your fingers first. Seth in there, Peter. Great stuff. And as I said, please, if you do not understand things, please do type questions. There is no such thing as a silly question. Good stuff. Lots of thumbs up. Thank you very much. Now let's have a little look at firmware and software. So firmware, we know, is essentially a type of software that exists. It's written into our non-volatile memory. Okay, that is normally put into our BIOS or EUFI. Okay, so it is a BIOS, basic input-output system, which exists on your computer. These are chips. They are written to chips on your system. They are not normally updated because they tend to be non-volatile memory kept in state by our battery on our system when we unplug it or turn it off. Okay, when you boot the system up, the first thing that tends to run is your BIOS system, and you can basically click into it or go into it by pressing a function key, F2, delete, F12, F11. It'll tell you which one when it basically runs through the pre-operating system test. And this takes you into where you can make some low-level configurations in the boot. There's some key points about firmware. It's embedded onto the hardware. It's normally put onto a chip that is soldered onto your motherboard. Think of it as read-only memory, so ROM, so it's read-only memory. It controls specific hardware operations, so it does help and control that before it hands it over to the operating system. Firmware is typically written by the device manufacturer. So the BIOS on a EliteBook, a HP EliteBook, will be written by HP. The firmware that is written onto my iPhone is written by Apple. And indeed printers. All printers and things have these particular items. Okay, so this is what we kind of have with the firmware. All computers have these things on firmware. And it's also not just all computers. Every other device, your printers have them, as well as your fridges all have firmwares, your smart cookers, all those devices will have firmware on there. Here's a couple of examples that are on there is key points are sent to the BIOS, as we said, and what you're more likely to run into now is the UEFI system, which replaced and updated the BIOS. Any questions around the difference between firmware and essentially an operating system. So you're all going to get this. You're all pretty good at this. Okay, no questions coming through. That's great. So under the hood then basically includes the boot methods. Now we all know when we turn on a machine, it does something, it starts. That starting is known as booting up. Okay, that boot basically is on a particular method depending on the device that you're on. So what your BIOS basically does in UEFI basically will check and see where it should be booting up. We've said within our BIOS and UEFI, we set a priority for our boot devices. In the old-fashioned days, it used to be a floppy disk drive. Then it used to be the hard disk drive. Now we have USBs and other devices in there that can boot off. We can boot off a network. Okay, we can dual boot. We can use a CD, USB, a network. So we can boot from any of these particular devices as long as we've configured it to do it. So a BIOS typically will basically use and read the master boot record, the MBR, which is a specific partition on your disk drive. Okay, and it will literally go, I need to boot from my hard disk drive. I'll read that sector, which is always written in the same location for every single disk drive. So it knows where to get it from. From that may come information about the operating system. And that's when it begins to hand over to the operating system. But as I've said, nowadays, we can boot off networks. So we can boot from a network server. I can boot my laptop. I can tell it I need to boot the operating system from a network device. And it will go out and it will find that network device, boot off of that. And that will then give me an operating system from my network. So this allows things that are typical, such as thin clients. Have a show of hands. Oh, dual boot. We're going to dual boot in a minute, Marcos. So let's have a show of hands. Who's heard of a thin network? Or a thin client? Paul's basically heard of one. That's good. Paul, what flavor of thin clients were you using? Never heard. There's quite a few that haven't heard it. I think we should probably go through it. Let's see what Paul's basically used. Both Dell and HP, yeah. Okay. So let's have a little chat about thin clients before we go on to dual booting. It's a terminal that basically uses a server to boot from. Yeah, that's pretty much a good description. So thin basically means you have no details on that local machine. This is a poor example. They are about that big. They can be a lot smaller. And the idea is that the device will have sockets on it that plug it into the network, the monitor, and the keyboards. Okay, keyboard and mouse. Okay, and the idea is that when that boots up, it goes, I haven't got any details about an operating system because I've got no disk drive on here. I've got no data. I've got absolutely nothing. All I've got is something that says I need to go to my network and boot off of a server. And that terminal server, which is what Microsoft used to call them, provides all the operating systems. So all the data can live in a centralized location. And that means if one of these basically breaks in an outreach office, all I've got to do is post them another one. That makes them very good. They're very reliable because there's no fan, because there's nothing really heating up in these devices. There's no disk drive. So there's very little that actually goes wrong on those devices. Makes them very good for outreach offices. As long as you've got a network connection, you're running fine. Does that make sense for terminals? Terminal services? We do cover it a little bit later as well. It's like having a PC away from a PC. You don't really sit at your PC. your PC lives out on the network. Okay, dual boot. Marcos wants to know what dual boot is. Just give me a second here. I'm just going to quickly check something. My apologies for that. Okay, so let's have a look at what dual boot is. My operating system, I can basically set it up with the master boot record so that it recognizes multiple operating systems. This allows me to run a disk drive that can have both a Linux operating system on it and a Windows operating system on it, or multiple Linux operating systems. So when I go into the UEFI, I can configure it to offer different boot options. So that means one day I can turn on my laptop and I can run it in Linux. I can turn it on the next day and I can go, I'll run it in Red Hat. And the next day I can run it in Windows. So they are basically all operating systems written onto the same disk drive and their own little partitions, separate partitions that are looked after. And that gives you the option. Now, we don't tend to do it massively nowadays because there are easier ways to do it because we can now use virtualization and virtual machines. And we show you a lot of virtual machines later on. Marcos, that's fantastic. Any other questions about boot methods? We used to have a lot of problems with boot methods years and years ago. I think I mentioned it last week with people leaving things such as floppy disk drives in the system because the operating system was very simply try and boot up off of that floppy disk. Half the time floppy disks have just got user data on. Oh, I'm talking ages old now, aren't I? Floppy disks. When I was young, we had floppy disks. But you can do the same with USB sticks. If you leave a USB stick in your laptop or in your PC, you turn it on in the morning. If your boot order says check the USB stick, you may get a message on the screen saying no operating system found. Don't panic, you probably just left the USB stick in it. Pop the USB stick out, get it to retry, and it'll probably boot off of the right device. But it's important to remember that is the order that it will boot from. Common issues they were. So let's have a little chat about some kernel partitioning. So the kernel basically manages everything. Okay, so the kernel is designed to select and create the disk partitions. Okay, there tends to be 3 essential device drivers or drivers for these things. Common interfaces such as the SATA, SAS drives, NVMe, which is the small memory ones that I've showed you, which is a SAS drive. Okay, so it understands these and it will partition them up. Think of it very much the same, like we had a pizza slice. We had spinning disks. In the old-fashioned day, the system used to basically partition those into segments. Okay, when those segments were basically allocated, that's what it basically did. So we do the same for SATA, we do the same for SAS, we do the same for those devices. So essentially, it is dividing the disk into logical sections. We call these partitions. And that allows the installation of multiple operating systems because it isolates the data so the kernel can control that. Okay, common partitions. We've seen these. Probably if you've built your own machine, you've probably seen a system partition, you've probably seen a boot partition, and a data and a swap partition. So we have these variety of partitions. Is anyone familiar with a swap partition and what that does? Probably going back a bit nowadays. I think we don't tend to use them massively now. So a system partition was very simple. It basically held the operating system, kept separate from the user data. We normally have a system partition and a data, kept separate. So if one goes down, we're not affecting the other one. The swap partition was sort of a sneaky entry years and years ago when we weren't able to get lots of memory in our systems. we would kind of cheat. We may have applications, hungry applications like Excel or SQL, things like that, that love to use a lot of memory, wouldn't be happy with the amount of physical memory that was on the system. So we would cheat and we'd lie to it. And what we'd actually do is we'd map some of that memory that was our physical memory onto the disk drive. And we pretend. So we take like 1 gig on memory and we'd kind of cheat and we'd make that 10 gigs on the disk drive. And that would be a swap partition. And that partition would be allocated and it'll behave like memory. It'll be slower, but it'll behave like memory. So we were able to fool our applications into going, haha, actually now you've got 10 gigs of memory. What are you crying about? Okay, but it'll be a bit slower. And that was the swap ones. We don't tend to see those massively now because memory's got cheaper. So we just buy more memory. It can still be used in Linux. Linux is one of those operating systems that a lot of people still write swap partitions in, and they use swap partitions if they need to. As I say, with the cheapness of memory that came around over about the last 5 years or so, or 5 to 10 years, we haven't really started using those again. So an MBR, which is our master boot record, is normally limited to 4 primary partitions. Okay, so the MBR is basically used in our old BIOS system. Remember our old BIOS we said was old? Right, whereas GPT supports many more. GPT was introduced with our EUFI. So you can see with a massive amount more partitions, we can do an awful lot more with the EUFI. Any questions around that end of things? Did I answer that question, Alan, about Linux? A lot of Linux operating systems, because they are so customized, yes, some of them will still very much use partitions if they want to fool the applications into thinking we've got shared loads of memory. Okay, so kernel boot methods. Let's have a look at the kernel's user cases. So we have a cold boot. So cold boot is clinically defined as if the system has no power in it, as in it is powered off, and you turn it on. Okay, that is defined as a cold boot. That means if you are currently running the operating system, if you shut the system down totally and then boot it up again, that is a cold boot. Everything powers down, power goes off, system restarts. Commonly known as the turn it off and turn it on again solution for IT technicians. Warm boot is very simply a restart, a reboot without removing the power, without turning things off. And you can get this from Windows, you can get it from the menu, you can do it in the Apple Macintosh as well. You kind of go start, restart. We're not taking the power off, we're not shutting everything down, we're just asking it to reboot. It clears out most things, but not absolutely everything, which is the difference between that and the cold boot. It's quicker than cold booting. We've talked about network boot. Now I'm going to mention something here, which if you do end up going into being a data center technician, a lot of network boots use something called PXE boot, Pixie boot. Okay, and this is what's used off of an ILO system on a HP hardware. And this is where the operating system will very simply use Pixie to actually work out what it's supposed to boot off of. Things such as thin clients, as well as remote deployments and maintenance. So if you're in a data center and you rack a server that has no operating system on it, you banged all the hardware in it, you've got all the right memory, all the right disks, you slide it into the chassis, you plug all the cables in. One of those cables is a network connection specific for Pixie boots. And what happens is when that system turns on, it will know its IP address or will get allocated an IP address on a VLAN, and it will talk to the Pixie boot. And that Pixie boot will go, I know who you are. I'm going to put this operating system on it, this applications on it. I'm going to configure it like this. And that means with the zero input from us, we can basically just slide the thing in and turn it on. And then we'll have an OS on there and everything that we need. Allows an awful lot of great remote server systems. Any questions about network boots? Good stuff. USB boot. Can anyone give me an example of where I would use a USB boot and why I would want to boot onto a USB? Hammer it into the live chat if you can. Computer OS. Paul Bird is basically put in there. So Rossano, computer OS. What am I doing with the computer OS? Paul Bird says Talos OS. Corrupted OS. Certainly, if I have a corrupted operating system and I'm unable to boot it, if I wanted to rebuild it, yes, I can boot off of a USB. And I can install a new operating system from it. So I can basically write onto one of these beautiful USB sticks the core part of an operating system. Sometimes it is just the piece that needs to basically access the network that then can basically download the operating system from somewhere else. But I can basically put the majority of the operating system onto a USB stick. So if my machine is dead or if I'm rebuilding it, I can boot off of this. It will not touch the SSD or the hard disk drive in there. And I can go, right, wipe out the hard disk drive and reinstall an operating system. I can give you a clean PC, laptop by booting onto that. Pressure says it can be used for troubleshooting. Yes, very definitely. If you've got a tricky machine, you can basically get special operating systems or just the operating system and the tools that are on the stick, and you boot onto that and you can run full diagnostics of the hardware by booting onto that without interfering with the operating system that's on the machine. So you don't have to install anything new. It's also quite useful if you're trying to get rid of viruses and things like that on systems because it's done in post. A lot of viruses basically wait for the operating system to load and then they take effect. If you've got one of those nice viruses that does that, then yes, you can boot off of this. You can wipe the hard disk drive, you destroy all the virus, and then you carry on. But it's not a golden bullet. Some operating systems do insert themselves early. Yeah, and okay, any other questions there? So that's definitely where we would use a USB. Traditional one, boot from disk, we all know about that. That's what happens 99.9% of the time. Turn the machine on, it boots from our attractive disks. But in the old-fashioned state, we also used to boot from CD and DVDs when we still had them in our devices. How many laptops nowadays or PCs actually have these? I haven't seen one on sale in the market for a good fair few years nowadays. They tended to die the death, didn't they? But we used to be able to do exactly the same as we did from USBs. Our operating systems used to come on these big shiny discs that were called CDs, and we plug those into the CD player, boot up, and we do exactly what we do from the USB boot in terms of we would install an operating system. Okay, and then we can have a boot for removable media. Very similar to essentially using our flash sticks or USB devices. We can boot from essentially a removable media that we can plug in and out. Great stuff. Here's a quick question. Let's smash an answer into live chat here. A multiple choice question. And we're going to have a quick break after this. We're going to have a 10-minute break after this question. Look at that. We've got a lot. What kind of operating system runs an iPhone? For a minute there, I outstand myself every now and again. For a minute then, I was looking at the live chat going, why is everyone typing C? Okay, C is the ABCD. I didn't realize that. I'm going to sit in the corner for 10 minutes. Good. Yes. Okay. So great. Well done for remembering that. Okay. So we're going to listen to some music. We're going to have 10 minutes for your coffee, your pancake, your comfort break, if you happen to need one. And then we'll come back in 10 minutes. Well, I hope you had an opportunity to have a comfort break, grab another coffee, an apple, a banana, or whatever it is you fancy doing. And we are ready to kick off the second part of this. Beautiful music, Rasha. Thank you very much. Let's have a thumbs up so that I can tell that everyone can see the types of installation. Peter, fastest fingers first. Marcos, Fintar, Alan Palo. Good. Okay, all ready and raring to go then. So we have different types of installations that we have. So we kind of talk about the local installation is probably the more common one. This is where the operating system is installed physically on the media on your system. Okay, it normally drops onto your SSD or your hard disk drive. Then we have our beautiful thin client, essentially, which is a network OS installer, which installs the stuff across a network configuration. Apple does this very nicely. If you go into the Macintosh and you reboot and say, oh, I want to totally reinstall my operating system, it will go out to the network, it will grab the operating system and chuck the new operating system onto your system. Also used in our network systems such as Pixie, or essentially mounting installation from file servers for remote services. It's becoming more and more common as we move much more to a cloud network infrastructures. And then we have our all singing, all dancing virtual machines. We do go into virtualization and virtual machines later on, so we won't go into this in a massive depth here. This is really where the operating system is installed within a virtual machine. So that virtual machine will run on a operating system. And we'll talk about that in some more depth when we cover VMs. And of course, we have our beautiful upgrades. So a lot of the time you will see on a Mac, you'll see a little exclamation icon in the system folder that will tell you there might be some upgrades. Windows also does this nowadays as well. And it lets you know there might be a new operating system available. Okay, and the idea is that when we install this operating system, it doesn't overwrite the entire hard disk. It simply overwrites the existing operating system and then switches over to it. So it preserves the user data and their configuration and everything else that the user had. And this beautifully allows us to upgrade systems again and again and again, the latest operating system without going, I have to wipe the whole hard disk, I have to install my users again. None of that stuff basically has to happen. So those are the 4 types of installations. Right, file systems and formatting. A fun topic if ever I've known one. So the file systems, okay, the purpose of a file system is to allow you to store data. These get written out to our disk drives, our hard disk drives, our SSDs, our soft disk drives, etc., or to tape drives, etc. Okay, and it allows us users and software basically to create, read, write, update, and delete files and directories. But the reason for the operating system is that we need to know how to do it, and there are different operating systems. A lot of them tend to be a hierarchical structure. So we're all very familiar with the file systems in Windows and Macs in terms of it looks similar to a tree in its configuration. And then we either have a root folder or we have a C or a D drive, and then we have directories that split off of that. And we have subdirectories in those, allowing us to create essentially a tree structure. And then the file system itself will also control how we identify the files, which letters can be used, how many numbers, how long that can be. So there are restrictions on what tends to get written down. These restrictions have disappeared over the last 20 years and become less and less so. But the operating system and the file system will control that, will maintain that. And then there are now attributes for file. So each file is associated with an attribute such as the size of the file, a creation date is stored with it nowadays, modification date, and permissions. And if you certainly run on Linux systems, you'll be very familiar with the term permissions, as in this tells you what can and cannot happen with that particular file. And it controls who can access it and whether or not they can modify it or whether or not they can just run that file. So let's have a look at a couple of typical operating systems. NTFS, New Technology File System. Okay, this is a Windows operating system. FAT, we all love FAT, it's File Allocation Table. It is the most commonly, well, wrong to say it's the most commonly used. It is the best transfer file system to use. So if you're moving data from a Mac to a Linux machine, from a Mac to a Windows machine, everything will understand FAT. It was a very early file system. ext4 is quite common in Linux distributions. It is not the only one available in Linux. Linux, because of the multitude of Linux operating systems and the way that people modify it, has hundreds of different file systems you can actually use, and they all have different nuances, all different flavors, all different attributes and facilities in there. Okay, so don't get tied up with the ext4 basically just being a Linux one. It is a common one. HFS and APFS. This is our beautiful Apple system. So, high performance file system and Apple performance file systems are basically used in the macOS. And of course, the thing with the macOS is that it's all controlled by Apple. Okay, so you cannot write your own file system and start running it on an Apple system. And many virtual models now will also use what is a VFS, which is a virtual file system, which allows a modeling layer for the virtualizations of file systems. Okay, so this kind of provides an abstract from the physical layer of a file system to a virtual file system that sits on top. And that will make a lot more sense when we start talking about virtualization. But what you're going to understand is that understanding these basic ones is really the foundation to then understanding the rest that basically come into there. So they all have different characteristics, as I've said. FAT32, which is essentially the base one, okay, has a maximum file size of 4 gigabytes minus 1 byte. Okay, we'll ignore that bit. Okay, file name, we all used to have to write names in an 8.3 file format. So we'd have 8 letters or numbers, a full stop, and then what is known as an extension. That's how we used to have to write things. Imagine having to write loads of different documents in that particular format. This is why you get so many weird and wonderful bits of jargon in the IT industry. And FAT32 had a partition limit, as in you could see a disk drive size of 2 terabytes. Anything bigger than that would have to be split into a second partition. Okay, you can see that is quite limiting. And that was a very early operating system. NTFS went, well, maximum file size, 16 octabytes. Wow, I've never seen anyone write 16 octabytes. It's proper database, proper large database size files, that is. The file name limits 255 characters. So you can now, instead of just having that 8.3, you can type, this is my file. I'm going to use it on every Tuesday of next month. Promise. Okay, and that could be your file name. No limits on the file name. And as you can see, we did expand the partition limit size to 256 terabytes. Okay, not something you're likely to get on your local machines, but it's important within our server environments. exFAT was a essentially improved file system, improved FAT, extended FAT. And as you can see there, they expanded the way that it handled the file names, the way it managed the partitions, and the maximum file size. You don't have to remember all these numbers, but it's worth just having a quick glance over them. HPFS, as you see, high performance file systems, 8 exabytes. File name again, 255. APFS, again, was pretty similar, wasn't it? Partition limit not specified. Not sure if anyone's bothered trying to build one bigger than that. ext4, again, is another big one. Again, you notice there that we tend to use 255 bytes for the file name limits. 255 is a common number that we will see in computing. So those are some typical file systems and the limits. They are no way the extent of everything. These are the common ones. I've said before, if you end up on a Linux operating system, you can have the guy around the corner in his garage writing your file system, and he can load it onto your system, and you'll be using Johnny's file system. And he will set maximum file sizes depending on how he's created it, file size limit, and the maximum partition size will depend on how he has written that file system. Any questions about file systems then? Yeah, I think pretty simple with file systems. So how this tends to look, on Windows, we see a C drive. We give drives letters. That's the common factor we used to do. Can anyone tell me in live chat why the general first partition that is used, or the drive letter is used, is C for the files? Why do we start with C? As in core? Good thinking there, Marcos. It's because Windows itself and the disk operating system, DOS, DOS, is a disk operating system, began its day on a floppy disk drive. Okay, the first floppy disk drive was allocated A, always allocated A. Then, by some magic, we went, actually, we're going to put 2 floppy disk drives into machines. I remember loading an operating system, then loading Excel using a 2 floppy disk drive system. We had to take disks in and out, put the next disk in drive B, put the next disk in drive A, doing this literally to load Excel. So the first 2 were allocated was A and B. And then someone went, let's put a hard disk drive in it. And then went, okay, that's C. Okay, we haven't lost A and B. They still exist. They're still allocated to a floppy disk drive if you ever had one. But that's why we start lettering from C in the Windows operating environment. Now, Linux, as well as the macOS, basically supports, we'll go into that as well. So supports a root directory denotion. So we do not have the idea of drive letters. And we'll talk about how we mount specific folders, file structures within Linux when we go into that. Okay, but generally the root is allocated with a slash on it. So instead of having C:\user for our user folders, we have \user in our allocation tables. Just different notation on it. And your Mac OS, because it kind of followed on from the Linux stuff, follows that similar sort of notation. You very rarely see it because on your Mac, you simply go into your file system and it goes, oh, there you go. You never see the root folders. Here's a quick question for you. NTFS is used by Microsoft operating system, true or false? Balls in straight away with true. Maximilian, true. Marcos A, yep. True. Yep. Smashing it through. Hello, Mateus, Fintan. Good stuff. Yes, it is basically predominantly used by Microsoft operating system. Could we use it on a Linux system? Yeah, sure, because we can load whatever operating system we like, whatever file system we like onto a Linux system. I'm sure Microsoft won't get upset with us if we put NTFS on. Anyone want to ask questions about operating systems? Sorry, not operating systems, about file systems. Okay, so let's move on to user interfaces in operating systems. The user interface is king, it's key. Sometimes referred to as the UI. Okay, it serves basically the port of interaction between us and the computer. The nicer this is, the more fun we have with it, isn't it? And therefore, the more productive we are. Okay, a lot of our user interfaces now are graphical user interfaces, commonly known as GUI. Okay, graphical user interfaces has icons, buttons, it has a little mouse we run across the screen, doesn't it, and have lots of fun with. So it is interactive, makes it very easy, such as Windows, macOS, desktop applications are all basically done like that. Other interfaces we have with our computers are command line interfaces. Okay, CLI, this is often abbreviated to. So this is where we drop into our text-based system. Let's have a show of hands. Who hasn't seen a command line interface? If I get one hand, I'll quickly show you one. You haven't seen one, Sebastian? Okay. This is a command line interface. Okay, it is a text window where I could type commands into. This is my Windows one, so I can type dir and it gets a list of the directory. CLS, does that clear it? Clear. I can type other commands that do different things. All done text-based. I've got no mouse I can use in it. It's all text-based. So that is a command line interface. Whereas what we see behind us is a graphical interface, a GUI. Is that clear for everyone? How do we like that? That was MS-DOS. Yeah, MS-DOS, MS-DOS was a command line interface. Years ago, we used to have to run Excel by coming to the command line and typing Excel and pressing enter. And that would start Microsoft Excel. You can still do that if you wanted from a command line interface nowadays. Why not click on the pretty icon though? Okay. Other interfaces. Okay, we have touchscreens now. I don't know. I mean, we've all used touchscreens on our mobile phones. A lot of laptops nowadays have touchscreens. Touchscreens can come in a multitude of sizes, not just our tablets, but we can also have massive wallboards. Okay, who's been into McDonald's? McDonald's has those crazy things that are on the floor, don't they? That you can stand on and walk around on. They look like puddles and things like that. Essentially, that's a touch interface again. Peter, don't worry, Peter. You've not seen one before. We will introduce you to the command line interface in more detail later on. Web interfaces, we see this. This is our browsers, okay? Commonly used for services, applications when we're interacting with our banks, purchasing something off eBay. Yes, we are using a web interface. So it's designed for common interaction. Last but not least, we have virtual reality. This is our augmented reality, where we basically put on a headset, we can have some controllers, but the interface is designed to give us a virtual reality. So those are the common interfaces that we have. Now, the importance of the user experience, UX, in this case, the user experience, is the first impression is really important. If we enjoy the interface, we're more likely to interact with it. This is what Apple basically did fantastically compared to Windows. The Apple operating system made everything intuitive. Okay, whereas Windows came from an environment that was essentially MS-DOS, so it's used by people who understand the command line interface, and therefore it was a bit clunky to start with. Now it's beautiful, isn't it? But Apple came in and they went, we don't want people to use the command line, we want people to use the mouse and click on things, make it pretty. And that's what they did. And that was really good from Apple. Then they made it really expensive. So the first impression, how does it look? How does it feel? Usability is important. Make it more user-friendly means we increase our productivity, love going to work because we enjoy playing with our operating systems. Accessibility. A well-designed UI considers the needs for users in terms of those with potential disabilities. Accessibility features such as screen reader, keyboard navigations, ensure that everyone can basically interact with your operating system. And then basically at the end, a good user experience streamlines the interface. Things are where you want them to be. If you have common things you're doing, they are in a common menu that is really easy to get to. This is why we have things such as the toolbar on the bottom of Windows. And we have a start menu that has our applications that we commonly use. And we have our most recently used list of documents and applications. These are all considerations for our user experience. And Windows, Mac, Linux, yeah, they're all pretty good at it. So there's some overview of the elements of the user interface. Menus, we're familiar with menus, I won't go into that. Buttons, well, we all are pushing buttons, don't we? So we all know what a button looks like. Text fields are input boxes for making individual items, not individual items, putting text in. We all basically fill this stuff out, okay, all the time, don't we, whenever we're using web pages and things like that. And we have checkboxes and radio buttons. The difference between checkboxes and radio buttons: a checkbox, you can tick multiple items in the checkbox list. A radio button, this stems back from the old days of the wireless, doesn't it? That you press one button and it pops all the others up. Okay, so you can only ever have one radio button pushed down. Any questions about those? Wow, we know we have a scroll bar on our system. We basically have vertical and horizontal scroll bars. These are all elements of our user interface. And the reason we do go through this is because it's asked in the CompTIA. Icons, which are just visual representations. Dialog boxes are things that pop out individually and they show us individual items that potentially will ask us questions and have checkboxes in it. And then we have drag and drop that allows us to select items in multiple ways, move the location and drop it into locations, drag and drop files and other things like that, don't we? Okay, very quick question here. Command line interface, CLI, is commonly used in the Linux and Unix environments. Nashil, yes. Paul Bird's fastest fingers first in there. Well done, Maximilian. Daiquiri. Sebastian, yes, true. Yes, very good. I'm going to turn this into a Kahoot quiz. It's so much fun. Yes, it is. Is it the only interface in a Unix or Linux environment? No. Beauty of that operating systems is that you can put whatever interface you want on it. You can have a graphical interface or a command line interface. If you don't like them, well, you just install a different one. Some other person might have written a different graphical user interface, and you can simply install that one instead. Bang, off you go. You don't have to feel fixed with those. Whereas the Windows, because remember it's a closed operating system, as is the Macintosh environment, you have to have the interface that is given to you. Great stuff. Okay, anyone got any questions about the interfaces that we use? Has anyone used a virtual reality headset? Who's done the Minority Report thing with the screen on and done the twisty hands and all that sort of stuff? Meta Quest 3, love them. They are great, aren't they? Sebastian wishes he has one. Okay, that's good. Okay, so that kind of brings us to the end of the roughy piece of the lecture. At which point there's going to be time for some questions later on. And what we're going to drop you into here is we're going to introduce you to Codio. Codio is our virtual environment where we let you play and break things. After we come back from the Codio, any questions you have about anything we've covered today or in previous lectures, I'd love to pick up any questions and answer it. But right now, what I'm going to do is I'm going to hand you over to Ragib, who's going to have a quick chat and run you through how to get on to Codio and how to run up a virtual machine. Ragib, you good? Beautiful.
All right. Can you guys see my screen? Okay. Hi, everybody. So we've already seen Codio. I think when we looked at the mini project one, so it takes you to that platform that is basically Codio. So we'll also use Codio for accessing our VMs. Just a quick overview of what a VM is. A virtual machine is basically a computer inside a computer, right? It has its own operating system. It has its own CPU, RAM, and storage. But it's all like software based. It runs on top of another system, which is called the host, right? So you might wonder, like, why would we want to learn how to use a VM, or what's the point, right? So as a computer support specialist, you can create a VM to test out fixes without risking a real system. You can, if you want to try out Linux but don't want to wipe your laptop, you can open a VM and use it. You can break things, fix things without hurting your actual computer, right? So in the real world, VMs are used everywhere, every day, right? So companies like Amazon, Microsoft, they use VMs to host websites, apps, services. Cybersecurity analysts, they use VMs to open suspicious files. And just like us, VMs are used a lot for training and education as well. So yeah, so we will be looking into VMs a lot in depth in the later chapters. But for now, I just want you guys to show you guys how to access it, right? So just a few requirements for the VMs. So generally, we recommend you use a Chrome-based browser, right? Either Chrome, Mozilla works as well, and always try to use it from your desktop or laptop, right? It doesn't work the best with mobile or tablets because it's a computer that you access. So it's the best experience is using a desktop or a laptop. Internet, that's pretty standard. And also make sure that when you are using the VM, you might get a pop-up for cookies, so accept them. And there's a quick guide how you can set that up if you forgot or you have it blocked. Okay, and there's some troubleshooting steps. So if you spin up the VM and you get a no VNC error, you just click on the click button and it will try to reestablish the connection. And there's a couple of buttons I'll show you guys. So if your VM is slow or acting weird, you can try restarting the virtual machine. This is basically restarting the computer. Okay, and do not click on the terminate VM button unless either one of us asks you to, because it's a no-no. So you'll see you shouldn't be doing this. This is only done in the emergency. So let's take a look at our training site. So do you guys all see the intro to Codio on your training site? Can I get a thumbs up if you guys can see this lesson? Let me just share. Okay, amazing. So we'll click on it, right? And it'll give us this prompt saying that we want to use Codio. It'll just redirect to that page. So it's just taking us, and anytime you want to go back, you can just click on the back. All right, so it's loading up. All right. So again, it tells you about the same thing that we saw on the slides. So this lesson is about a virtual machine introduction. So how we can access a VM through our Codio platform, right? Uh, so there's a couple of ways you can access it. And generally, it will be a set window for you to access that VM, but you can also access it from, uh, one second. Oh, I think it's disabled. Never mind. So let's go to the next page. All right. So as you can see on the right-hand side is booting up our virtual machine. I hope everybody sees a message like this that is turning on the computer, basically. Please let us know if you see something different. So it takes a little bit of a time. Again, this computer is somewhere else in the cloud that we are accessing. So it takes some time to turn that on and establish a secured connection. %. Yeah, it takes a minute. So let's wait for it to connect. So as you can see, my one has booted up. So if you want, you can always make this smaller, and because if you want, or you can make it full screen, however you like. So this is basically a VM, right? So it looks just like a Windows computer, laptop, desktop, right? But it is hosted somewhere else, basically. I'm just gonna wait a couple of minutes for you guys to boot up. Let me know once you guys are in the screen, and we can do the exercise. Okay, Marcus says he's in. Okay, so that's great. That's no issues so far. It's a very simple exercise. It's basically just, trying to get comfortable with the VM and how to make changes and whatnot. So on the step one is asking us to change the wallpaper for our virtual machine. So it would be just how you would change in your own desktop if you have Windows. So we'll just go to the start menu, then we go to the settings, right? And it's a bit slow again because this is a remote connection, right? So we are using a different computer in the cloud from here, so it wouldn't be as the same latency as using a desktop in real time. So you will see there is a bit of a lag, and that's absolutely normal. So we'll go to personalize. So personalize icon, and then we would select an image from the bottom. So let's select this one, and then we just choose the fit. And I think that's pretty much it for step 2. So we just select it, and we use the fill option, and we can see that our background has changed to the image of our choice. All right. Okay, so how many of you have managed to complete step 2? Okay, amazing. All right, pretty simple so far. We just have one more step. This one is also very simple. So it wants us to change the wallpaper for our lock screen. So again, very simple, very trivial. We go to the lock screen. We choose a picture of our liking, and that's pretty much it. And if you want to see it, we can go to the start, go to administrator and lock. And we should be able to see the lock screen. Okay. Any questions so far? Any problems? Does anybody need any kind of troubleshooting? Yeah, so no, you don't have to. This is basically just to get you comfortable to how to use the VM. It's basically like a computer. Ideally, I wouldn't save anything in this computer, just because I am not sure if it gets saved. Uh, uh, I don't know if Rasha knows about it, but I am not sure if a new instance gets boot up every time we log in. So let me see. Yeah, they get wiped. So that's what David is saying. So yeah, new VMs get booted up every time you log in. So I would just use this as an exercise basis. So if you're doing some exercises, just do it as of now. Don't save your information here. It might not. Uh, it might not be saved. Yeah. Yeah, VMs are a bit laggy just because we are accessing it over the internet, right? So it wouldn't be the same experience. But sometimes when you work in tech support or computer support specialist, you might have to remote access to someone else's laptop or computer to troubleshoot. So that is a very similar experience, right? So that lag is always going to be there. Okay, and there was a question in my chat. Let's see. Control delete. Control Alt delete is unlocking. I'm on a Mac, so it might not work for me either. So this is the case. I can restart the VM. I think this should work. Let me just give it a try. I think this works. I had this issue last night. Rosano, you had a question. Are you on your laptop? If you could try using the virtual machine, I mean, the recommended speed is 5 MB, but it might still work. I would recommend you give it a try and see if that works. Peter is saying that he can't get into the exercise. I'm using a Samsung tablet. Yeah, I would recommend you can go. I mean, if you have, let me see. Yeah, if you can, this will be available in the training site, so you can go home if you have a laptop or a computer, you can practice this. But as of now, it wouldn't work from a tablet or a phone. All right, give me 1 second. Uh, Let me see. Okay, Mati. Okay, I see. Give me 1 second. Let my this thing boot up. There should be an option on the side. I reset it my VM, unfortunately. But do you guys see this option? You should be able to use this to use the keyboard. To use Alt delete Windows key. All right, I just have another request to show this again. So again, I'm just gonna do this one more time. Let me just exit out of this. Let me see. Maybe I can just go back. Okay. All right, so let's just go over this one more time. So if you're on your training site, you should see week 5, lab 1, intro to Codio. So clicking on this will take you to your Codio page. All right, so yeah, so mine is still shutting down and restarting, so it's gonna take some time. Hopefully sooner. No, you can actually full screen it. That's nice. Uh, Sorry, I'm just waiting for this to shut down and reset. If you guys have any questions regarding anything else, you can feel free to drop it in the chat. Can unlock the VM. Okay, let me take a look. Mine is just restarting. Uh, this is inactive, bro. Ooh. Okay. Let's see, how do I get this started again? Yeah, if you're done with the task, you can mark it as complete. My thing is booting up again, so once this is up and running, maybe I can see about the unlocking. Okay. Okay, so there are some buttons here. So let's see. Keyboard. So not sure how do you no. Delete. Okay, you expired. Let me try that again. If I log this, I should be able to unlock it. So here, let's go all windows. No, all delete. There is no delete button here. Kind of weird. This is copy. You can just cancel that. Yeah, I don't know, David. How would you unlock this?
I think the Control Alt Delete is the bottom three buttons on that one. I think once the VM seems to be locked, it doesn't seem to allow you to unlock it in that manner. We can obviously take that offline and we'll have a look at that.
Okay, all right.
Please don't lock your VM. I mean, let's
Okay,
not
all right.
show people.
Okay. So if you guys are stuck in this, I would recommend you can do the restart VM, and then it will take some time to shut down. And then one is shut down, then you can refresh the screen.
Yeah.
Yeah.
I mean, the beauty of
But
the
for
VMs
now,
is that, sorry, the beauty of the VMs is that if you do get into a horrible position where you have to have reconfigured it all and it's gone a total nightmare, it's restarting the VM should basically give you a clean system again.
yeah, yeah. So for now, if you're done with the assignment, if you're locked in the screen, I would just go down and mark it as complete. But if you want to explore it again, I would recommend click on the restart. It will shut down, wait for it to shut down, and then refresh. Come back to Codio, it should work fine, just like me. And again, if it doesn't work, just reach out to me. We can take a look at it. But again, there's nothing more to do with this VM specifically. We're just trying to show you guys how to access it. Okay, I'm gonna stop sharing and we can pass it to David.
Thank you very much, okay, that was great. When you see basically that we give the flexibility there for you to pop into Kojo, you can play with the VMs. We give you some really simple tasks to start with, but as we drop into the operating systems, we'll be playing more with some of the configurations, and we do that with both the Windows environment and the Linux environment. We unfortunately don't do it with a Mac environment because we're not allowed to run the Mac OS in a virtual environment for any training purposes. Thank you very much, Apple. So let's kind of close things off. Hopefully, if anyone had any big problems getting onto Kojo and doing any of those particular tasks, Ragib has already put his hand up once already. Yes, get in touch with Ragib, book a 15-minute, half an hour slot. Make sure you can get onto those because they are good fun and they are kind of part of the education and the learning that we'd like you to do. It's much more fun playing with toys rather than just being spoken to them about it. So as a conclusion for literally for the lecture, yeah, we talked about the different operating systems. We talked about some of the market share and the fact that Windows is much better than the Mac OS, much better, much bigger than the Mac OS. I love the Mac OS as well, don't get me wrong. I've got a couple of systems here that are Macs as well. And we just kind of mentioned the differences between what you get on the mobile devices, the laptops, the desktops, and indeed we'll talk about the server systems as well at some point. Important takeaways are really the function of the kernel and what firmware does and the boot processes. So pay attention to those. You'll also need to be able to answer some questions about the file system. So the operating system that your file system basically runs. Okay, so you'll have to ask some sensible questions about that. Potentially remembering that FAT is the portable one that can go between any operating system because they all understand that. And then some specifics probably about the Windows one and probably more about the Mac one, but nothing really heavy and deep in there. So I said